They're doing the best job possible. Back in 1980, NASA gave a grant to Oklahoma State University to develop a system to be able to analyze airplanes operating just like they would in the field. And that has continued on for several years. And last year we were here to check Tommy's airplanes. We're scheduled to be here again. Actually, we intended to do that today, but Mother Nature wouldn't let us. But we do two or three things. On the dry materials, I have one of the collectors that we use here. We set up 25 of these collectors, and if you can't see that, they're made out of fabric supported by a metal frame. The idea with the fabric is when the particles fall down, it's sort of like taking a baseball and throwing it against a quilt hanging on the line. It absorbs the energy and it doesn't bounce out. So we get a real high collection efficiency. They have a small tube on the bottom, and we extract all those and weigh them and form a plot that characterizes what the swath width looks like, how wide it should be, and since we know the area of this, we also can tell them exactly what rate they're putting out. It's a good way to check it. For the spray systems, it's a similar type thing, but the collection media is a string. Now today, if it was below freezing and you were driving down the road, what part of your automobile is going to freeze first before you start noticing ice? You know? Pardon? He says the windshield wipers. That's not necessarily right. Anybody else want to make a guess? It's usually going to be your antenna. You watch your antenna. When that antenna starts to grow in diameter, you know it's starting to freeze. Now, why would the antenna collect it quicker than the large surfaces? Because air can't go over those large surfaces. They move around. The small particles would freeze quick, move with that air. But the antenna sticking up there is a really good collector. The small particles would freeze. We use a 1 millimeter diameter cotton string, which is actually collected. We feed that through a machine that we have here called the fluorometer. It's a cheap machine. You know, it's a $25,000 instrument that we feed that material through, and it develops a plot from the computer. So we know exactly how wide they should be, and we know whether they have high spots or low spots, because an airplane, they're a little different than ground applicators. Anybody know what makes an airplane fly? No, somebody said when.
Money.
Over here I was talking a while ago, said he had a pilot's license. Where'd he go?
You got the wing, you got the front.
No, that ain't it. Do you know what makes airplanes fly?
Wind. Air.
Nope, that's not it. It's money. If you don't believe it, you just go buy it. Okay? I guarantee you that's right. But because we have the propeller on the front, and just to keep the pilot cool, you know, if it stops, he's going to sweat. But anyway, because it turns one direction, the way the nozzles positioned are not always uniform. We got to put more in one spot, less in one spot to make sure that we have uniform pattern. And that's what I'm trying to do. It's what we've done in the studies from NASA. On the dry material, when I was doing my PhD program, I did modeling on dry material, the ballistics of all of that. In addition, on the spray system, we have a scanner, and the company that I have has written a software package where we can actually count the droplets. We can give a complete distribution of how many small droplets, how many big droplets, how many medium-sized droplets. And why would we want to know that? Because this guy's got some crops. He doesn't want Tommy to drift them, okay? And we want to know that we get good coverage on the plant. So knowing exactly what the droplet sizes are is very important, both for the efficiency of the application, how well it works, and for how safe it is in terms of movement. So we get a complete analysis of those. Generally what we do in Arkansas, and I've retired 30 years with the University of Arkansas, is we have community workshops. At the community workshops, the guy brings his airplane in, and he has to compete with everybody else for a slot to be able to analyze that and don't have a lot of time. Tommy's Flying Service has contracted with us to do a private workshop. So we come here, they have 3 airplanes, we spend all day looking at all the different rates they want to put out, looking at new technology if they have some, looking at both wet and dry to make sure that they're doing the best job possible. So when they start on you guys' crops this year, hopefully they've got everything tweaked out so they know what to expect, they know what the airplane's doing. So it's a good service. Spend a lot of money to do that, and hopefully you get the best benefit from that. So it's real nice to be I'd be happy to answer any questions if somebody had a question about how we do that.
Dennis, one thing I'd like to add to what Dennis said, this year we have the capability with one airplane to do variable rate drive. So if you do the sampling, grid sampling over the field, we can do the variable rate application of fertilizer with one of the airplanes.
Technology's changed a whole lot. There weren't even turbine airplanes. The first time I came to this business was back, you remember what year it was, Tony, about 81?
85.
Or somewhere along in there, and there was this little shed out here, none of these buildings existed. And there weren't any turbine airplanes either. They were all much smaller, and so they've gotten better. There's a lot of concern about turbine airplanes, the way they operate, but every aspect of those airplanes has been designed to do the best job possible. So they're getting better and better. We have a lot fewer airplanes than we had when I started 35 years ago, but we actually have more capacity in terms of the number of acres that we can do with the fleet we have now than we did when it was 3 times as big. So, a lot of changes for the better in terms of that, but since there's a lot of money involved, being able to calibrate those and do that is an excellent service. We do that. I own a company that does that. We did it in 35 locations last year. Canada, Australia, South America, Africa, and the rest of them across the U.S. Days like today when Mother Nature kicks us back a little bit, it's kind of hard to fit everything in, but we're doing a lot of that. We see about 500 to 600 airplanes a year, and we don't necessarily know more than anybody else, so we get to evaluate with the way they work, and we try to transfer that technology to everybody that we go see. So you can lead a horse to water, and sometimes we can make it drink if we do enough of it. Any other questions or comments? Glad to be here, and we'll be around. I just want to introduce my technician. This is Lynn Baxter back here. Lynn's, she doesn't look like it. She's a pilot. She's both a pilot, back to commercial pilot. She did work on an airport, and she's been trained and qualified. One of the things that we have to do to analyze this stuff in this program, as an engineer, I have to get 15 CEUs, continuing education units, every year to keep my engineering license. I have an aviation insurance business. I have to get 12 CEUs every year to keep my insurance license. But in order to be able to calibrate the airplanes, to be certified to do that, I have to get 10 CEUs a year just to stay current to be able to do the airplanes. Even though we're doing it all the time, we have to comply with those requirements for CEUs. So the people that are doing this, and Lynn's one of those folks that keeps up with the CEUs, are staying abreast with the current technology, like the different rate technology, all the controllers that go in that, and the airplanes are just getting better all the time. With that, glad to be here, but we'll be around, either myself or Lynn, to answer questions from anybody might have. Thank you.